Uh, Sorry for the delay. Hello, my name is Warren. I'm an intern at Source, and this is my very first talk. Um, so today, um, I want to talk about programming languages migrations on GitHub. So I'm sure everybody here has, at least once, has even thought doing an obscure project. Well, I could do the job with this programming language, but why not switching to another one? So here, we want to answer the following question, which is, how strong are the flows of developers from a language to another one? You can read my presentation on your device if you want to click the links or zoom the visuals. It's also available on my github.io. So I'm working currently at Sourced in Spain, and my background is mostly mathematics. I studied physics and moved to optimization, and because I love math, and I code in Python. My company is called Sourced. It's based in Madrid. It's about 20 people, and we are fetching all repositories from GitHub, Bitbucket, and we aim at doing source code on top of this code, so that we need to turn this source code into AST, and then we can do machine learning on top of it. So it's been 2 years we developed the source engine so that we can allow developers to use our technology, and it includes several tools like SourceGoGit, Bubblefish, etc. I invite you to take a look at them. About the story of programming languages. So everything started from this blog post from Eric Bernardson, the eigenvector of why we moved from a language X to language Y. Well, where Eric tried to quantify the number of Google queries, on Stack Overflow, of people said, okay, move from Scala to Java, etc. And he built a matrix, and he concluded that Go was the most popular language based on Google queries. So when Sourced opened the dataset of distribution repositories last year, I thought we could take a look at this issue of popularity of languages, but not based on Google queries, but based on real source code, which is repositories. So, well, our dataset, just few figures, it is 4.5 million GitHub users, nearly 400 different languages, and in total, it stands for 10 terabytes of code. Well, if you take a look at a sample of this dataset, it's a user, a GitHub user. I found it convenient to take a look at each GitHub user with that kind of Gantt chart. So this is a guy that coded from 2012 to 2015, and we see that he mainly coded in Scala, but he tried to code something in 2012 in Go, but didn't really get along with this language, because then he coded a big project in Java, and finally in Markdown. So this is the history of the languages used by this guy. And here I just wanted to notice that it would be completely nonsense to say that, okay, the guy in 2014 moved from Java to Markdown. We can't say this, because we can't compare languages that are not comparable. They don't have the same purpose, So here's a huge assumption I had to make. It is that, well, first we focus on transition of languages between 2000 and 2015. Well, that makes sense. 2015 because that's the end of my data set. But I choose to focus on 20 comparable programming languages well, and I decided to exclude JavaScript for several reasons. So you might be angry at me because of this, I don't know. But the thing is that JavaScript was everywhere, on every account of every developer on GitHub. So it absorbed completely the study. And furthermore, like if you're dealing with JavaScript in the front end, you're kind of stuck to it anyway. So there's no point of moving from JavaScript to another language. And if you use it in the back end, it is often refers as Node. And our data retrieval team couldn't make the difference between those two languages. So, well, quickly, the data set includes Hello World projects, whatever size projects. And you agree with me that coding such a little script wouldn't count for moving from a language to another one. So I quantized the data set. This is in orange the distribution of contributions on GitHub per size. And the blue curve is the KDE approximation. So if you just divide the area under the curve into 10 same areas, you can say that, okay, the first area, it's like the contributions equals to 0, etc. And so it makes the study clearer in terms of noise removal, simply. Well, here we need to compare, we need to find a distance to measure the transition of a developer between languages. So this is how I represented it. You can see two vectors here. This is a random GitHub user, and you have on the left the vector of his contributions in 2014, and on the left and the right the one in 2015. So, and the values of the node are the number of bytes coded in that language. So here you have two distribution, and you want to compare it. So you need to have a distance, and well, in the literature you can find many different distances, like simply the Euclidean distance, but I choose to use linear programming here to compare those two languages because I love optimization, and because more in general, linear programming is very fast to compute. So it was a good choice here. It consists in introducing flows between those two distributions, and if you see those values in terms of amount of time dedicated in a language, you want to find the minimum cost flow of this problem. This problem is it's a general transportation problem, and I used the Earth Smallest Distance implementation in the PIEMD package. This is the mathematical formulation of the transportation problem behind what we just saw. So we just want to minimize the sum of the flows, which is the x here, and c is just the cost of the flow, but we assume that we set all the costs to 1 because we don't want to make assumptions in our problems. And the two constraints here, it's just usual transportation constraints, where we would like to say that we need to satisfy the demand, which was on the right, and we can't exceed the supply, which was on the left. Of course, the flows are positive. And there is a solution to the problem because of this hypothesis. We have this because we have normalized the histograms, so it's just equal to 1. So solving this, we have at the end a flow matrix per user per pair of consecutive year, and if you sum everything, you have this matrix. So well, how to read it? Well, it's a bit hard to see, but for example, here you have Python, and the lighter it is, the stronger is the value. So you can see, of course, that a lot of people move from C++ to C, from, I don't know, from Python to Java here, etc. And the diagonal would mean that a lot of people stick to this language. So it's a bit hard to understand what's happening here. So there is a little of work here. Because our main question was, we wanted to find how the probability that a developer moved from a language to another one. So here we are looking for the importance of the languages. You can say importance, you can say popularity, but this is the main thing behind it. It's called the centrality measure. I'm sure you've heard about this. It's the kind of measure like you want to compute when you want to know in a, for example, the Facebook network, when you want to find the most important guy in the network, which has who has the most influence, you know. We are doing exactly the same thing with languages. And the popularity is, we're going to reach it computing the eigenvector centrality. So we are looking for an eigenvector. There are several algorithms to find them, but we have to work on the metrics a little bit. So mainly, there is 3 steps. The metrics has to be stochastic, acyclic, and irreducible. So very briefly, we make the previous blue matrix stochastic by normalizing the rows. So we have probabilities now. And because all the values in the matrix were strictly positive, the matrix was irreducible. You know, you had not like some kind of spider traps from, I don't know, people moving from Lua to Clojure and Clojure to Lua and never to other languages. You don't have this because all the values are positive. So you always have a way to reach a language from another one. And this theorem, the Perron-Frobenius, just said that because the values are positive, we are looking for the dominant eigenvector, which means the eigenvector associated with the highest eigenvalue, which is 1. So we miss the way that the matrix should be acyclic, and this kind of matrix has already been, I mean, people at Google worked on it, and Larry and Sergey find a nice trick to make the matrix suitable for algorithms. It's called this approach is called PageRank, and basically it's just updating the transition matrix, which is P, like this, where beta is called random work factor, and doing this, you have only positive values in your matrix. Your matrix stays stochastic, and you have the acyclicity of the matrix. So now we are fine to apply the algorithm to have the eigenvector. This algorithm, I choose power iteration because it's damn simple. You just have to multiply a vector, random one, by the matrix again and again until convergence, and you have convergence because you have these 3 properties. At the end, you obtain a nice vector, which is the stationary distribution of our Markovian process of moving from a language to another one. Okay, so in few words, it is the popularity. This is our vector, and the highest value was for Python, and on the right, I just put the amount of the relative amount of source code so that you can understand. You can compare. Like for example, PHP. A lot of projects are coded in PHP on GitHub, but its popularity is not so high. It's as high as Ruby, whereas the source code is 2.5. Well, I'm not going to check it, but a guy just sent me the annual statistic of GitHub this morning, and you can see that the ranking is almost the same. You just have JavaScript on the top because they didn't exclude it. Well, if you take our former Blue metrics, you did all we have talked about, like normalizing the rows, removing the diagonal, and sorting the metrics by our popularity vector. You obtain this. And so this is the same way of reading it. Like you can see that, for example, let's take, I don't know, Jupyter Notebook. People coding in this environment are most likely to move to Python. I don't see the probability, but it might be something like 60%. So it makes a lot of sense. And you can spend like days and weeks just looking at these metrics. You have a strong relationship between Objective-C and Swift, which makes also sense. Same thing with Scala and Java, where it is, like Java, no, Scala and Java here, etc. And you see that, for example, numerical languages like R, Fortran, I don't know, MATLAB, they are most likely people coding in that language are most likely to move to Python. Well, to obtain the Blue matrix, I sum all the years. But if I look at this dominant eigenvector sequentially year per year, I could plot the evolution of this dominant eigenvector, which is this stack area plot. So mainly the eigenvector with 70% for Python, it's this one. And I plot the others so that you can feel the evolution of the popularity of languages from 2000 to 2015. So this is not an absolute study. You have to keep in mind that it is related to the choice of languages I choose at the beginning. But if you compare those 20 languages, you obtain this. So, well, you can just take a look at it sequentially. Like, I don't know. You can see that C and C++ are going, well, less popular, but it's not really that because a huge amount of code is here. So it's just that people started to code even more starting in 2010. So it's just relative popularity. But if you take a look at, for example, Objective-C, here this date, 2014, it's when Apple announced that people should switch from Objective-C to Swift, because Swift started here. And you can see that the layer of Swift takes the place of Objective-C. And this is the way of reading it. You can see that Perl is, well, I don't want to fight with Perl coders, but their language is doing pretty bad in terms of popularity, seeing this plot. And Python seems to be the big winner here, but I didn't know I was talking to Pitata. Well, to finish, this is few other study we made at Source. The first one is my projects I'm doing right now. I'm developing a model to predict your next command you're going to write in your shell based on your own history. It's based on sequence-to-sequence learning, and I hope people would use it pretty soon. And this is my contacts, and above all, the contacts of my startup Source. that is highly looking for people as we are growing really fast. Well, thank you.